Good morning, Year 12s. Today we're going to look at investigating associations between two numerical variables, and this is something we'll spend quite a lot of time doing. This video is largely a recap to do with scatterplots, correlation, and how we measure the strength of it. Alright, so say we want temperature, for example number of people on the beach, and we're going to create a scatterplot. To do this, we go to our calculator, we title it here and here. Traditionally, you put what's going to be the x variable there and the y variable there, just remembering that this one, the x variable, it should be the explanatory variable, and the y variable should always be the response variable. You'll then type in all the numbers, and I'll pause while I do this. Right, done. Now, typing numbers can be boring, yes, but you need to be able to do it accurately and quickly, because in the SAC especially, there is a pile of data to work through. Alright, now, please write down these steps, because in the test, you may well forget, which would be incredibly frustrating. You want to insert a new page, so Control-I will be the hotkey there, and you want to insert data and statistics page. It should come up. On the bottom here, we wanted temperature, so that would be our explanatory variable, goes along here, and on the Y, we wanted the number of people on the beach. Excellent. One beautiful little scatterplot. Of course, you should be able to do that by hand, but you typically won't be asked to. Calculator is by far the quickest, most accurate way to do it. Note that if you're doing it by hand, you wouldn't generally do the way they've skipped the axes there. You would do even step sizes. Alright, now, moving on. Once we've drawn a scatterplot, how do we interpret it? And if you're asked to comment on the association between two variables or asked to describe the scatterplot, you must mention several things. You must mention the direction and if there are any outliers. So a positive correlation is one that looks like that. A negative is one that looks like this. You want to comment on the strength. It'll either be weak, moderate, or strong, and we'll look at how to classify that in a second. You want to comment on its form. Form being either linear or non-linear. Now, we will look at how to do that in another lesson, and it's largely based on judgment, but there are a few tricks to help us there. And lastly, it's good practice to offer some form of interpretation. So you don't say that temperature causes more people on the beach. We're very careful to not mention causal relationships. You would just say there appears to be a strong positive linear association between temperature and the number of people on the beach. This indicates, the interpretation part usually starts with this indicates. This indicates that days with higher temperature tend to have more people on the beach. Note that I'm not saying days with higher temperatures cause more people to come to the beach. I just say when one is high, the other tends to be high. Or when one is low, the other tends to be low. And we'll do more on that correlation causation later. It's one of my favorite lessons. Most of you have probably seen it before. Alright, so values of R. R is also known as Pearson's correlation coefficient. Sometimes in the exam they will just call it Pearson's coefficient or the correlation coefficient or R. Essentially, when they mention any of those four words, you should be thinking calculate R. Now, there is the formula for R. By all means write it down. You'll never ever need to use it. Finding R is your calculator's job. So let's do that. Here we have our correlation. To find R, what we do is we head back to this page, where we've been before. Go menu, statistics, stat calculations, and we wanted to show a linear regression. And typically in this course, we use the form a plus bx. And we'll talk more about a and b later, but you want a plus bx. Along the x is our explanatory variable, meaning temperature. Y is people, the response variable. And then we go, okay. Alright, now, we can ignore a and b for now. We'll look at them more later. What we're interested in is R. R is 0.95. So what we do is we look at our table over here. And we say, well, if R is 0.95, it's between those two. We would say there is a strong positive correlation between temperature and the number of people on the beach. I would strongly encourage you to either print this off or copy it down exactly. Those are the VCE's number boundaries, and you're expected to be able to use them. Alright. Now note, there are 3 assumptions when using R. R is only valid when these 3 things are true. Firstly, all the variables are numeric. Fair enough. Secondly, there is a linear association. R doesn't really work if there's no linear association, and we're assuming that there are no extreme outliers. Extreme outliers will throw R off a considerable amount. So sometimes the VCAL people will ask you what are some of the assumptions. There are the 3 of them. All right. Coefficient of determination. Now, don't get this confused with coefficient of correlation. Coefficient of correlation measures the strength between the 2. Coefficient of determination is slightly different, and it is R squared. It is achieved by taking R and squaring it. So here, we could take the value for R, 0.95, square that in our calculator, and we would get out R squared. Easy enough. Now note, there's a trap here. Sometimes, and this is one of the hardest questions you'll come across, sometimes they'll give you an association which looks like this. And they'll tell you R squared is 0.64. And you're like, okay, so R squared 0.64. And they'll ask you to find R. Now what most people do is they say, alright, excellent. If I have R squared and I want to find R, I just take R squared and square root it. So R squared square rooted equals R. So therefore I would take 0.64 and square root it, which would equal 0.8. Sorry, my computer's going really slow. 0.8. Now, that makes sense, doesn't it? Square root 0.64 gets 0.8. The issue is, if we look up, 0.8 falls here. Strong positive association. Now, what I've drawn in this little sketch is in no way positive. It's negative. So, those of you who remember quadratics, remember that if you square root something, often there are 2 answers. For example, if I take 0.8 squared, it makes 0.64. Easy enough. If I take negative 0.8 squared, it also equals 0.64. So there are 2 solutions here. When we say square root of 0.64, there are 2 possible solutions. It's either 0.8 or negative 0.8. And what we have to do is we have to consider the association, and we would say, well, that there, the R value, would be negative 0.8, because that there is the negative slope. Does that make sense? And we will do exam questions like that later. Alright, coefficient determination. The coefficient determination determines, as a percentage, tells us the variation of the response variable that is explained by variation in the explanatory variable. So up above, we would say, with our temperature and beach example, we would say that 90%, because that's close to 90, really 91%, 91% of the variation in the number of people can be explained by variation in temperature. When the markers are marking this, they'll be looking for you to use variation. The word variation, they're really not flexible. You need to use that word, and you need to use it twice. The coefficient of determination tells us that 91% of variation in number of people on the beach can be explained by variation in temperature. Alright, apologise, it's a long video. In fairness, you've got the whole weekend to watch it, so it should be alright. Alright, an example here. So, if you're completely comfortable with above, you can play this on triple speed and just get the example down. But what we're looking at here is constructing a scatter plot of the data, commenting on the correlation, and making an estimate of R, calculating R, calculating the coefficient of determination, then writing the proportion of variation yearly profit increase can be explained by the variation in the advertising budget. They're basically giving us the interpretation of R squared here and asking us to use it. Alright, so if you feel comfortable with this, feel free to skip this section. If not, one more example. Alright, if we're asked to construct a scatter plot, first step, let's go to our calculator. And I have entered in the budget and the profit data. So what we're looking at is the advertising budget in thousands is the explanatory variable, and the profit is the response variable. You could imagine that an increase in advertising could cause an increase in profit, and that helps you determine which is explanatory, which is response. Right, now we would like a graph, so data and statistics, and on this variable here, we would like to find advertising, or budget, and on this variable here, profit. Once again, it looks strong and linear. So, construct a scatter plot. Comment on the correlation of the advertising budget and profit. Make an estimate of R. Alright, so I would look at that and say there is a strong positive linear association between budget, advertising budget, and profit. This indicates that companies with a higher advertising budget tend to have higher profit margins. No, I didn't say cause, tend to. Similarly, an estimate of R, that's pretty strong. I'd be going 0.96, 0.98. Right, now let's actually calculate R. So back to the original page, menu, statistics, stat calculations, linear regression. We want budget, profit, leave the others, okay. Oh, my guess of 0.98 was pretty good, 0.98. Alright, calculate the coefficient of determination. You just do 0.98 squared. 0.98 squared is 0.95. Then write the proportion. It would be 95%. Oh, computer's completely frozen. Of the profit can be explained by variation in advertising. Sort of. Alright. Hopefully you have that down. You'll need to be able to get quick at using your calculator to do those processes, and very good at determining R and R squared. Thank you very much.